Okay, on the subtopic 2, we are going to find the roots. Subtopic 1 tadi kita find roots. Subtopic 2 pun kita cari roots juga. Cuma in subtopic 1, 4.1, we are using graphical and numerical method which is the changes of the sign. Okay, numerical method is using changes of the sign. And then for subtopic 2, we are going to use tangent, or we are going to call it as a Newton-Raphson method. Okay, so we are having a formula, don't worry. Okay, if you try to look at here, I already told you to revise it a little bit before giving the video, right? Okay, if you try to look at here, this is just some explanation, not some, this is explanation actually on how can we have the formula. Okay, so this is the formula. Okay, I just want you, in the Newton-Raphson method here, I want you to do a lot of practice. It is not advisable to just memorize, but you need to know how to use the formula. Okay, so by looking over here, actually we'll be using a tangent. Okay, just a little bit. So kalau baca kat sini, okay, baca dekat sini, they are using some tangent. Okay, Newton-Raphson method, let's say you are having some graph. Okay, I'm just explaining a little bit here, some graph here, and this is your curve, and you are going to find these roots. Okay, you are going to find the roots. Okay, you are going to find the roots over here. But how can we find the roots? By having some tangent. So if you try to find the tangent, of course you are going to derive this curve will be having the fx. So you are going to derive the fx here, the first derivative. Okay, and then you'll be using this formula. Okay, the Newton-Raphson method, which is this one. So you will be using this formula on how can we have the most approximate form, the most approximate roots that we can have. Don't worry, we are going to see it together, the example, so that you can understand better. I hope so. Okay, use Newton-Raphson method to find the roots of the equation x e power of x is equal to 1. So kalau tengok dekat sini, if you want to solve the x, it will be hard for us, right? So correct the 3 significant figures. Okay, it is important, 3 significant figures. Okay, so let's see it together. We already have a solution. So if you try to look at here, first you need to write the equation. So the first step, you need to write the equation x e power of x is equal to 1, as x is equal to e power of x, e power of negative x, which is you are going to have x is equal to 1 over e power of x actually. Okay, the approximation to the roots of this equation may be determined by drawing the graph. Okay, so because of we are going to draw the graph, which is the graph of this one. Okay, 4.6 here, you are going to draw the graph for the y is equal to x, another one, y is equal to e power of negative x, which is you've got it from here. You pindahkan dia kan, tadi dia beri e power of x is equal to 1 kan, x is equal to 1 over e power of x. You've got it from here. Okay, so then the next one, you are going to sketch this graph. So you already have the graph. So by looking over here, the blue color is e power of negative x, and y is equal to x is the red color here. And approximately here, which is that's why I asked you please have your graph paper to help you to approximate the intersection points that we have. Okay, so from the diagram, approximately we'll be having 0.6. Okay, so approximately 0.6 here, we are going to take it as the value of x1 is equal to 0.6 here. Okay, so we're going to have this one. X1 is the first approximation. So we need to find a better approximation. How? X1 dah jumpa. So nak cari X2 pula. The formula for the X2, it will be equal to X1. X1 is 0.6 just now. We've got it from our graph here. Okay, so then the next one, substitute the formula X1 minus with X1, which is fx is x e power of x minus 1, is it right? So here, and then over with first derivative 0.6. So you need to derive first. Your fx here will be having e power of x in the bracket x plus 1. So you'll be using your calculator. Substitute the value as 0.6 here minus the value that we'll be having here. We'll be having 0.5680. And then the next one, since the question asking for 3 significant figures, so maybe it's very advisable to have, maybe you'll be having 4 decimal places, okay? Then the next one, because we are going to round up, right? So then the next one, move forward, you need to find for the next value for the x3. So now when the x3, we are going to substitute the value of x2, which is 0.5680 minus with the first derivative, substitute the value of x2 here, and then you'll be having 0.5671. And then here you are, if you try to look at here, since the question asking correct the 3 significant figures, okay, actually 3 decimal places here, but dia lebihkan sikit. So by looking over here, x2 and x3 will be having 0.5671, 0.5671. So the number that we have here will be equal, which is dia akan sama. So bila sama, this is our answer, 0.567 here. So I hope you understand about this one. Don't worry, we have more example. Please redo it again. Example 4.7, the question asking, prove that the equation has one real root between 1 and 2 by taking 1 as the first approximation. Okay, so find this root corrected to decimal places. So the first step, which is in this one, okay, what can you do? We are having example 4.7 here. So the first step, okay, you already know the x1 here, it will be equal to 1 sebab dia dah declare dah. It's already declared here. Taking 1 is the first approximation. x1 is equal to 1 here. And then the next one, you already have your fx given to you, which is x cubed plus with the x minus 5. Find your first derivative of fx. It will be equal to your first derivative, it will be equal to 3x squared plus with 1. So having this one, this is important. So after you've got this one, so then the next one, which is, it is said here, you need to know. Dia dah kata apa? Prove, right? So you need to prove, you need to show. The equation has one real root between 1 and 2. So you know from the subtopic 1, in numerical method, which is, you know the changes of the sign. When you substitute f1 and when you substitute f2, there is changes of the sign. f2 here, there is changes of the sign, means it is proof. Okay, means what? Means you can write over here, it is proof that we have one root. Okay, we have one root between x is equal to 1 and x is equal to 2. Okay, this is one of the things, and we haven't done yet. Next, what can we do for the next one? Of course, we are going to use your Newton-Raphson method, which is, as we know, it is given to you, x1 is equal to 1, and then which is, we are going to find your x2. So to find your x2, it will be equal to x1 minus with the f x1 here over with first derivative x1. Okay, substitute the value, means you'll be having is equal to x is 1 minus with f1 over with your first derivative here, 1 here. So your x2 here, it will be equal to 1 minus with negative 3 over 4 here, it will be to 1.750. And then let's proceed to find your x3. It will be equal to x2 here minus with the x2 over with first derivative here, x2, and so on. If you try to look at here, don't worry, they have a solution. For the x2 will be having 1.750. Well, if you try to look at here, x3 will be equal to 1.543, x4 1.516, and x5 1.516. By looking at here, x4 and x5, we are having the same answer since the question asking correct to decimal places, right? So we can round up. If you try to round up the x3, you still have 1.52. You round up 5x4, you still have 1.52. But if you try to round up the x3 here, still 1.54, right? So dia tak sama lagi. Kita akan cari jawapan yang akan sama. Tengok dekat x4 dengan x5 ni. So jawapan dia sama. And round up, since the question only asking correct to decimal places, 1.52. I hope you are clear about this part. So then the next one, we have another one example. Okay, please stop the video and try to do it by your own first. I'm going to explain later. Okay, example 4.8 show that the equation e power of x is equal to 4 sin x has a root between x is equal to 1 and x is equal to 2. Find this root, correct the three significant figures using the Raphson method. Okay, so if you try to look at here, given to f x is equal to e power of x minus 4 sin x, declare dulu siapa fx kita. So after you declare our fx is equal to e power of x minus 4 sin x, can. So then the next one, find the derivative of fx, which is e power of x is equal to 4 cos x. So then the next step, of course, you are going to define who is your x1. But in this case, if you try to look at here, we are not sure who is your x1. Dia tak state pun. Example 4.7 is already stated the x1, but here example 4.8 is not stated what is our x1. So what can you do over here? You need to sketch a graph. Okay, so you need to sketch a graph here, your x and y axis. This is your e power of x, and approximately this is your 4 sin x. Then the next one, you will be having your intersection points. Okay, so intersection point there, that's why it's very helpful if you're having graph paper. Okay, so we are just going to take this one, which is 1.36, because of what? It's already said here between x is equal to 1 and x is equal to 2. So 1 is somewhere over here and 2 is somewhere over here. So between 1 and 2 will be this one only. So we are not going to take this one. So I hope you're clear about that part. So after you've got x1, so x1 is approximately, okay, x1 we are going to assume approximately 1.3. Okay, so then the next one, of course, after you've got your x1 is equal to 1.3, so you need to find what is your x2. So your x2 here will be equal to x1 minus with your f1 here over with your first derivative here, 1. And then you are going to find the value of x2 and x3. Okay, I'm just going to give the answer so that you can try to substitute the value by your own. So for the x3, we'll be having 1.365, something like this. For the x2, approximately, we'll be having 1.37114. x3 will be having 1.365. x4 will be having 1.365, something like this one. Okay, so if you try to look at here, x3 and x4, we have approximate number. We have the same. We have the same answer. So since the question asking for three significant figures, right? So you can say 1.36, 1.36. So therefore, the conclusion is 1.36 is our roots for this example 4.8. Please have the please have a full solution for example 4.8.